Okay, if you want to abbreviate conjugate acid and conjugate base, your option is you can write C period base or C period acid. But you only write the word conjugate on the product side. You will never write conjugate on the reactant side. Okay? Okay, now, there's a definition at the bottom of this page that you should know, and it's the definition for a conjugate acid-base pair. Conjugate acid-base pairs are substances that differ by one hydrogen. So let's take a look. NH3 and NH4 plus 1 differ by one hydrogen. That means they would be a conjugate acid-base pair. So NH3 and NH4 plus 1 are a conjugate acid-base pair. You have to know the definition and you have to be able to identify them. Okay? Then H2O and OH negative 1 are also conjugate acid-base pairs. Okay, so every equation that we look at should have two conjugate acid-base pairs. Does that make sense? Okay. Okay. When you're done with this, I need to look at something at the top of this page. Good. Okay. All right, at the top of this page, they give you some sort of like bubble diagram thing. So let's look at what we've got. This white sphere is a hydrogen ion. Make a note that hydrogen ions are extremely reactive and immediately combine with water. So that means hydrogen will combine with water. So there's those two. And then they form this, the hydronium ion. So what you should know is that hydronium and hydrogen ions are really the same thing, since hydrogen is really never found in solution by itself, because it's so reactive. So it will combine with water to make hydronium. So that means hydrogen ions are the same thing as hydronium ions. Okay, so if you're trying to figure out how many hydrogen ions there are, look for the hydronium ions that you have. Okay, know the name and the formula for hydronium. I will probably ask you about that on the test. Okay, and then let's turn to the next page. What time do you have to leave for the game? 1:15? 1:20? Okay, we're fine. Okay, next page. On the next page, there's a sample problem. I want to do the sample problem, and then we'll talk about amphiprotic substances on the page after that, and we're done. Okay? So, let's look here. Let's do number one. What would I partner HF with on the product side? Which one? This would get partnered up with what? Have to be the F. Okay, so reading it from left to right, are we gaining or are we donating a hydrogen? Okay, according to the Bronsted-Lowry definition, do acids or bases donate a hydrogen?
Acids.
Acid. So you would write acid above HF. What do I call its partner on the product side?
Conjugate acid.
Conjugate base, because it's the opposite of what we called it on the reactant side. Okay, I'm going to use a different color, and we're going to partner up the CN negative with the HCN. So going from left to right, are we gaining or donating a hydrogen? Yeah, so here we are accepting a hydrogen. So what do I call CN negative 1 according to Bronsted-Lowry? Yeah, this is a base, which means its partner is a conjugate acid. What are my conjugate base pairs? Give me one of them.
HF.
Yeah, so HF and F negative 1 would be a conjugate acid base pair. And the other would be, yeah, CN negative 1 and HCN. So if this were a free response question, like on a test, make sure you are including the charges if there are any on the ions. Does that make sense? Like if you just gave me HF and F, wouldn't be right. It would have to be HF and F negative 1. Okay? Okay. One more problem. Number 2. If I ask you to write the conjugate acid of something, what you're going to do here is you're going to add 1 hydrogen, and the charge increases by 1. So I have 2 examples. I have these 2. Okay? So we're going to add a hydrogen, and we're going to bring the charge up. What do I get when I add a hydrogen to this SO3 negative 2? H, SO3, and the charge goes up 1. What does it become? Negative 1. What happens if I add an H to H2O? H3O, and the charge becomes what? Plus 1, because this was neutral over here. This had no charge. Okay? Let's go in the opposite direction. Conjugate base. You want to remove 1 hydrogen, and the charge decreases by 1. So we're going to do these 2 examples. Okay? If I remove a hydrogen from this one, what does it become? Yeah, charge goes down 1. The charge here is neutral, so it goes down to negative 1. And then what do I get when I remove this hydrogen? CO3 negative 2. Yeah, this goes from a negative 1 to a negative 2. Okay, last page. Okay, on the last page, we're going to talk about substances that act as both acids and bases. So these are called amphiprotic substances. So water is the most common. Okay, let's go over here. So I'm going to highlight water in both of these reactions. On the left, water is acting as an acid. On the right, water is acting as a base. So that means here, water is giving a hydrogen to something else, because that's, according to Bronsted-Lowry, it donates hydrogen. And over here, water is actually accepting a hydrogen from something else. Okay? So, amphiprotic means it has the ability to act as an acid or a base, depending upon what it's reacting with. Water is a common amphiprotic substance. You absolutely need to know this. Water is the only neutral substance that will be amphiprotic. All of the others will be anions. Okay? So this one is the only neutral substance that's amphiprotic. There are none other for you at all. Okay. The other amphiprotic substances are anions. So many anions also display amphiprotic tendencies. Anions have negative charges. What else do they need? They must have a proton, meaning a hydrogen, to donate. So here, or be able to accept one. So basically what that means is, do you see these three examples that they gave you here? Mm-hmm. They all are anions. So all of these are anions. Plus, they all contain a hydrogen. Okay, so memorize water is the most common amphiprotic. The other ones are anions with a hydrogen. Period. We're going to do quick check number 3, and then you can work on your homework. Okay. Okay. Let's come down here. And it says, circle the amphiprotic substances in the following list. Oh, be careful. All right. Let's look at A. What would you say? Yes or no? No. This is actually acetic acid. It's neutral, right? When you look at it, the formula is neutral. Only water, which is neutral, can be amphiprotic for you, okay? The next one. Yes, absolutely, because isn't this an anion? Because it has a negative charge, and it contains a hydrogen. How about C?
Yes. Oh, no.
Anion that contains what?
A hydrogen.
Does that contain a hydrogen?
No.
No, it's out. D?
No.
No, it's neutral. It's not water. It's out. E?
Yes.
Absolutely. Anion contains a hydrogen. We're done. Your homework is open.